Good afternoon. Yeah, my name is Umar Yusuf, and I work with the Federal Polytechnic in Nasarawa State. I'm an academic staff there, and I am a freelance GIS developer. So the title of my presentation is using Python for GIS and remote sensing operation. The slide and the notebook are available on the link on the slide there. You can get it at any time. So the content of the presentation as follows. I subdivided the content into 3 major sections. The first section is going to be the overview and overview on GIS and remote sensing. The second part will be how Python is related to GIS and remote sensing. Then the third part is going to be the demo. So getting started with the overview of GIS and remote sensing. Let me first of all ask the audience, is there anybody who is from one of these geospatial data related fields? I mean anybody from geography, geophysics, land surveying, land navigation? Anybody here? Nobody. I can't see any hand. That's interesting. Then it means I'm going to have a very tough time explaining what geography is. But I know that in Nigeria, geography is a compulsory subject in secondary schools. Am I right? Yes or no? at least in the science classes. So well, whether you like it or not, you have been interacting with GIS tools. I know that many of us have used Google Map here. Many of us have have map applications, either Google Map or Bing Map, Yahoo Map, whatever map on your devices. Am I right? And so also in the course of this conference, there is the welcoming page. Sorry, not the welcoming page, the venue page that has a map of this conference venue on it. And the developer of the page also encourages the users of the attendants to use the conference to use the map to find their way to locate the venue, to locate the conference venue. And I happen to be one of them too. I have been hoping to get the conference venue address for a long time. That's after the application and so on. So I waited for a long time. I didn't get the conference venue till like remaining about a week or so. So when I got it, and I'm not familiar with Lagos environment, so I said, okay, how do I find my way to Lagos? How do I find my way to the Lagos, to the location? So I went to Google. Before I went to Google, I went to the page, and I was opportune to see, okay, there's even an option of getting the direction to the venue. So immediately I type in Abuja, since I was coming from Abuja. I type in Abuja and then click on get direction. And it showed me it took me to Google Map, where it showed me 2 possible routes from Abuja to Lagos. And one of them was by road, the other one was by flight. So if you have done that, if you are like me and you have done that, you are already using GIS. You are already doing GIS. Are we together? So GIS basically is all about location. It's all about maps. When you have a map of Nigeria, for example, you attach attribute or data to the map. You are already doing GIS. Remote sensing, on the other hand, is all about acquiring data or acquiring information from a distance without having physical interaction with that object. For example, as you're looking at me now, you are able to read my color, my skin color, the color of my shirt, the color of my trousers, and so on, without having physical interaction with me. That is remote sensing. Your eyes are sensing me. That is what remote sensing is all about. But in the geospatial world, or geospatial industry, what we do with the remote sensing is typically a camera mounted on a satellite. And the satellite is moving above the earth and acquiring or capturing images of the earth's surface. So later on, we are going to see some of these, the benefits of that. So then, talking about the application of GIS and remote sensing, or the application of geospatial information, or geospatial data in general. There are so many applications. In fact, I have a link on the slide that has about 1,000 areas of application and use of GIS. But at the moment, I would like to mention just maybe one or two prominent ones. If you heard of crime mapping, crime management, who have heard of crime mapping in this before? How about transportation management? You have never heard of anything like transportation management? Nobody. Disaster management. You should be aware of that. After all, there was disaster scenario in Lagos recently. I think issue of flood. Was it Lagos or Benue? So, well, GIS and remote sensing are used for managing those kind of scenarios. So, in GIS and remote sensing, the primary data sets are categorized into either vector or raster. And just as you know, vector is made up of points, lines, and polygons. While raster is just in form of a pixel. So if you have used graphic software such as Photoshop, CorelDRAW, and things like that, the concept of vector and raster is the same in those graphic software and in GIS. So when you have a point, for example, you can represent a town as a point in GIS. So that is a vector data. Then if you are representing a town, maybe you capture the satellite imagery of Lagos town. As you are representing the town as in form of satellite imagery. Then that satellite imagery is an example of raster data. So there are tools in this trade. And generally, they are classified into two, either commercial or open source softwares or tools. So in the open source, the leading or the top tool there is QGIS. While in the commercial option, the leading tool there is ArcGIS. So those are the two major tools in GIS. So these traditional tools, both of them support Python as their primary scripting language. And that is why this talk is being presented here. So why is it that most of the leading tools decided to choose Python, while there are other languages such as R, VB, C++, and so on? Well, the simple reason is because Python is flexible, efficient, it's easy to learn. I can continue with so many reasons why they decided to choose Python, but time will not allow for that. So let's talk about the relationship between Python and the GIS and remote sensing. So there's a popular saying in the GIS industry, in the Pythoning committee, that if it exists, then there should be a Python module for it. Even if there's no Python module for it, a Python developer can develop a module for it. So the same thing is applicable in to GIS tools. So there are so many native GIS, Python GIS modules or tools, in which we are going to look at some of them very soon. So the two leading platform or tools for GIS I mentioned, that is QGIS and in the open source and ArcGIS in the commercial option. Both of them have support for Python. The module for ArcGIS, the Python module in ArcGIS is called ArcPy, while the Python module for QGIS is called PyQGIS. So if you have those either of the software and you want to script Python, so those are the modules you call import ArcPy or import PyQGIS, and then you continue with your normal scripting as usual. So this is the interface of QGIS, and as you can see, the Python console is open, and we have a print hello GIS and remote sensing there. So remember that the name of the module is called PyQGIS. Then the interface of the ArcGIS, the Python module there is named ArcPy. So let's concentrate on the native tools, native Python GIS tools. So for vector data processing, we have tools or modules like Shapefile, Fiona, PyShape, and so on. For raster data, we also have options like OpenCV, Rasterio, Scikit-learn, GDAL, or Goodal, however you pronounce it, and so many other options. So I know that most of you will be surprised, why am I putting OpenCV there? OpenCV is enough for image processing, or what do you call it? Computer vision. Am I right? What's the relationship between computer vision and GIS? So, well, let me mention this. The concept, the programming concept you have in ArcGIS, in the normal programming concept of computer vision, artificial intelligence, deep learning, and so many other ones are also related to the GIS industry. They are basically the same things we use. So other modules include GeoPy, PySal, PostGIS, which is an extension for PostgreSQL database, and so on. You can find more modules on PyPy. Wow, so this is the demo aspect, and I hope it won't fall my hands. So I'm going to open a Jupyter notebook. I hope we all know, we are all familiar with Jupyter notebook. Am I right? I've had so many talks about, so many people talk about data science already. I know that those guys are gurus in using Jupyter notebook. So I'm going to walk you through a story. And the story is, I'm looking at tourist attractions, places of tourist attraction in relation to the PyCon, the Geo in PyCon NG 2007. And in the process, we are going to get some addresses and perform some geocoding on those addresses. I will tell you more about geocoding later, very soon. And also, we'll visualize those coordinates on a web map. And subsequently, we'll work with vector and raster data, just to get you familiar with GIS to get you familiar with GIS in Python field, or in Python programming. So usually, Jupyter Notebook is just is usually open in the browser, and I have it open already. So first of all, I'm starting with working with coordinate system. So remember, I told you that the story is I'm coming to Lagos, and I needed to visit some places, some top places of tourist attraction. So I'm not familiar with Lagos very well. So I asked a friend to get me a list of at least places I can visit after the conference. And then he provided me with a list of close to 17 top site attractions in Lagos. So please, I'm not sure if these are the main places that's as in the important tourist attractions in Lagos, but this is what I have in the list. So I have this list. What I needed now, as somebody who is not familiar with the Lagos environment, is to be able to locate the places. We are talking about location. So I have the name of the places now. How do I locate them? How do I visualize the relationship between those points, between those places? Which place is closer to which one? And that is what we are going to use the native GIS Python tools to answer very soon. So I go back to my notebook. So first of all, I will introduce you to Quanah Systems because it's a very important concept in GIS industry. And if you don't get it, then you will not be able to do or perform so many tasks in GIS. So Quanah Systems are just like, we have the globe, the earth is covered by an imaginary lines. Imaginary lines running from north to south and from east to west. Those running from north to south are called lines of longitude. And those from east to west are called lines of latitude. This is a diagram showing that. And this concept is closely related to what you have in the maths. That's why the Cartesian coordinator systems in maths. If you remember your class, your maths class very well. So, remember I told you that I'm going to convert the addresses I have into coordinates so that I can see them on the map and then visualize them with some other details or some other parameters. So there is a module called a GeoPy, and that module is used for geocoding. And geocoding is all about converting addresses or landmarks names to coordinates, that's to longitude and latitude. So what I did is to lay my hand on the GeoPy module. And the GeoPy has so many APIs it can connect to. The top three there are OpenStreetMap, the Nominating API, the ArcGIS API, and then the Google Geocoding API version 3. So there are other APIs, but I'm not going to consider them at this moment. So the first thing is to import all the necessary libraries. And the libraries are as seen in the first cell. After importing them, then I added the Excel file, the CSV file, into a pandas data frame. After adding it into the pandas data frame, I now use the GeoPy module. I first of all use the nominating option to convert those addresses into coordinates, longitude and latitude. Then I use the ArcGIS API to convert the same address into longitude and latitude. And then use Google version to do the same thing. This is the result for OpenStreet nominating API. So, but if you observe the result, if you take a look at the result, what we have there, some of the places could not, the API could not extract coordinates for some of the locations. For example, like Bar Beach Tower in Lagos, the API says it doesn't know it. Slave Trade House, also, no coordinate. But others, like Conservation Center Lagos, it was able to get the coordinate as this, and other places. And look at National Theatre Lagos. Look at the coordinate he got. The coordinate is obviously not in Lagos, because Lagos is situated between longitude 2.5 to 4.5, and latitude 6 to 7. That is the extent area coordinate coverage of Lagos. So if you are getting any coordinate outside this range, you should know that you are not in Lagos. The location is not in Lagos, so something is wrong. So what I did, I compared the 3 APIs. I loaded them into a data frame and subsequently saved them in a CSV for better visualization. So this is the table comparing the 3 API coordinates. As you can see, Google longitude and latitude are here. The ArcGIS API longitude and latitude are here. Then we have the OpenStreetMap API and longitude are here. I have them here in the CSV for easy comparison. So if you look at each API has its longitude and latitudes. This is for Google, this is for ArcGIS, and this is for OpenStreetMap. So if you look at, Google was able to get the location of almost all the points, apart from 2 locations, Slave Trade House and Oba's Palace. Idoguran. I hope I pronounce it right. So it was not able to recognize these locations. But look at ArcGIS API. It was able to get almost all the longitude and latitudes for all the locations. But some of them are obviously not in Lagos. For example, like this conservation center, Lagos. These coordinates cannot be in Lagos, of course. So also, if you look at this, cannot be in Lagos. Then the third API. The third API is the worst. It has about 6 to 7 locations that it doesn't recognize. So what I did was to settle for Google. So I settled with Google. After all, Google is well known and is very popular. So I settled Google, and then I continue with my story. So if you needed to, the coordinates are in longitude and latitude. If you needed to carry out something like a measurement, that's linear distance measurement, you want to know the distance between maybe one point to another. With the coordinates in longitude and latitude, you will not be able to get the accurate distance. So you need to convert those coordinates into a Cartesian coordinate, that is XY coordinate. So there is a library called PyProach, which I have imported above. So I used it to convert the coordinates into the longitude and latitude into XY. So I just did it just for demonstration's sake, but it's not necessary at this point, because I know that somebody may come up with a question like that how do you go from geographical coordinates to maybe rectangular coordinates? So the last 2 columns here is the column that shows the XY coordinates. And I use the Google longitude and latitude for that. So continue with the story. Now I have the places, all the addresses in longitude and latitude. I needed to see them on the map. So I use Folium to visualize the points on the web. So after importing Folium from the beginning, already you know, I converted the data frame column into lists. Then run the Folium library, apply the Folium library, and then I'm able to visualize the points on the map as seen. So these are the places of tourist attraction in Lagos, visualized on the map. So, but I'm not done. I needed to know which of these places is closer to the conference venue. So the next thing I did was to obtain the longitude and latitude of the conference venue, and also the longitude and latitude of my hotel. And I decided to plot add those locations to the map so that I will see which of the places of tourist attraction is closer to me, either from the conference venue or from my hotel. And that is what this particular cell list is doing. And as you can see here, I have my hotel in red, and then the conference venue in green. So, and immediately you can see that we have a target that is within the range, and that is our Kalakuta Republic Museum, which appears to be closer to the hotel, Prince King Hotel. Is that correct, Lagosians? Lagosians, is that correct? So if that is correct, then I know that, yes, I have a target, I have somewhere I can easily go to, maybe after the conference, and then give my eyes some food to eat. So the next section is to work with working with a vector and raster data. So there are so many packages or modules that allows you to work with raster, vector and raster data. And one of them is PySHP. So I have already imported it from the beginning. So I have a shapefile located in this directory, which I just open, and then I'm able to read in the shapefile and carry out some manipulations. So instead of using a typical or traditional GIS software, I'm interacting with the shapefile directly using native Python library. So a shapefile is just a file type in GIS. Just in case if you don't know what a shapefile is, just like the way you have a .doc for Microsoft Office document. So we also have a shapefile in the GIS industry. Then talking about raster data, raster, as I have mentioned earlier, that raster is imagery, is representation of geospatial information in pixels or cells. And a typical example is satellite imagery. So I would like to mention that the technology of acquiring satellite data is something that is very, very complicated. And I will quickly run you through the process. And then, yes, I will quickly run you through the process before my time ends. So there are so many satellites orbiting the Earth. Nigeria has about about 7, is it 7 there? 6 satellites orbiting the Earth. And I think the latest one based on this record is Nigerian Sat-2, which was launched in 2011. So this particular website, n2yo.com, has a service of tracking all the satellites in the world. So as at the time, before I came on stage, the Nigerian Sat-2 satellite was in somewhere around China, orbiting the Earth. But I'm not sure if you are seeing the location of the satellite here. On this page, you are supposed to see the satellite, the current location of that satellite. So I go back to my slides, to my Jupyter notebook. Out of all the satellites, one of the leading satellites around the world is the Landsat. And the Landsat satellite has been in existence for almost 40 years now. So for over 40 years, this satellite has been acquiring data for different purposes. And it is managed by NASA and the USGS. Yeah, I think this is showing. So based on this map now, I don't know what location is this, but this is the current location of Nigerian Sat-2 satellite, somewhere in the North Atlantic Ocean. So usually satellites will take like about 16 days to repeat its orbit. So if you want to get access to the satellite imagery, a good source you can use is the USGS Earth Explorer. And the USGS Earth Explorer is at this address. I'm not sure if you can see it. It's earthexplorer.usgs.gov. So if you go there, you register, you subscribe, you create an account, you search for the area you want to get the satellite data for, you insert the date range, maybe from 1993 to date, and then you click on data set, you select the available satellites there, and then if you have additional criteria, you go to the additional criteria tab, and then specify more criteria, and then at the end of the day, you get to the result tab. So on the result tab, you see different satellite imageries that ranges between the date period you selected. So when you download the imagery, you now have a raster data, which you can extract more information from. So in some of the native Python packages, you can use to work on raster data includes OpenCVs, scikit-learn, GDAL, GeoRaster, GPy, Rasterio, and so on, as I've mentioned earlier. So this imagery is actually the imagery of part of Lagos, satellite imagery of part of Lagos that I downloaded just to show you how the imagery look like. So this is from Landsat 8, which is the latest satellite image, latest version of the Landsat satellite available. So with this, I've come to the end of the talk. I say thank you. And
thank you so much, Umar. This is impressive work. Thank you. Any question? Questions? Okay.
My question is, apart from, do I say, prominent landmarks in Nigeria, is it also possible to do sort of geospatial, I don't know what terminology you call it, for normal addresses? So take, for example, I live at number 39, somebody's street, Lagos. Is it also possible to get coordinates for such kind of information? And how reliable would that coordinates be?
Okay, you mean you want to get satellite data for your location? Okay, the coordinates of your area, of your location. Okay. It is very simple. There are so many ways you can actually get the coordinate of wherever you are. I think the simplest one should be your smartphone. On your smartphones, some smartphone comes with a GPS. So using the GPS, you can get the coordinates of your location. Or if it doesn't come with GPS, you can download an app, a GPS app for the smartphone, and you can use that to get your current location. I hope that answers your question.
Good day, everyone. I'm Vincent. A few months ago, just before I graduated from school, I intend to design my final year project based on GIS. That was early this year, but I went through a lot. I can't even explain right now. I was trying to I saw Dubai, places like India, and they have street view of their environment. So I was thinking I could implement that to have a street view of my school that foreigners can really view my school online without being there. So, so many things had to be put in place. I was told that I had to meet up with some persons in geographical aspects. Yes. But such courses such as survey and others were not being offered in my school, so I just could not follow up. So I switched to mapping the street, the main road from my school down to Ilorin, which was about an hour. I schooled in Umar Landmark University. I finished from there. So the pitching, the potholes and all that, and implementing it. But time constraint would not allow me. So my question is this: how would you encourage someone, for instance, when you asked earlier, those courses that you listed, very few or no hands were up. How would you, someone in computer science or related fields, who is interested in setting up something like this, which is a kind of an interdisciplinary stuff, how do you come up with a platform that can help them to learn on time and implement projects as soon as they can? Is there any framework that can help you to just pick the graph or longitude and latitude points of certain area and just work with it, come up with 3D views and all that? I don't see any platform that can really help one, because I really want to go back to that project. And I fell in love with map problem in my final year. I eventually did one on the shortest path algorithm, and that was what I eventually did for my final year project. So I don't know, I still want to go back to that. How do you encourage someone like me to fix such problem fast?
Yeah, thank you. There are three main disciplines that made up GIS. The first is geomatics. Second is maths and statistics. The third is computer science. So as a computer scientist, you have a role in GIS. And as I've listed so many packages, so many Python-related GIS packages you can use for your mapping work. And that leads me to something I wanted to mention before I ended my talk. That is a Python group or Python conference called GeoPython. You can actually get the address at geopython.net. So the conference started about, I think, 2 years ago, 2016. There was a conference on GeoPython, just pure GeoPython. 2017 too, the conference took place, and 2018 there will be another conference, I think in Switzerland also. So if you go to GeoPython, you get a lot of information about GIS and Python stuff there. Thank you.
Thank you. Please, let's keep the question very short. Yeah, I'll make it a question.
All right, thank you very much. Does this work in real time? For example, you just talked about your hotel, and you are able to know the resort area around there. Does it work in real time such that when you move away from there, and you are still moving around Lagos, it's able to adjust and tell you, just like you have your real-time Google map, you still redirect and tells you another point or location that is closer to your current position. Then secondly, if I want to pull out all the data around for example, I commute around Lagos for like 3 months, and I want to track down the data and pull them down. So maybe probably I analyze and find pattern around how I move monthly or yearly. Is it possible to do that?
Thank you. Talking about real-time tracking of the points, based on the presentation I did now, is not real-time because the data I'm accessing are directly on the local disk in a CSV file. After grabbing them, I save them on a CSV file. So it's not real-time, but it's possible to implement a real-time solution. As you move, the coordinates will be changing. And that is the concept of Google Map. When you input a destination address, as you move towards the address, the coordinates is changing and it's guiding you until you get to the final destination. So it's possible to implement a real-time solution. Then the second question was? Yes. Yes, in that case, you will have to use a storage device, something like maybe a database or a text file. As you move or as you navigate within the environment, the coordinates are being captured and added to the database. So when you are done, anytime you want to visualize, you can get them, request for the data, and then visualize it on the map. Of course, it's possible. Yes.
Just a quick reminder,
Yes.
one question, please, and please keep it short. Thank you.
Okay, my name is Michael. I worked for a period as a researcher, and I visited some communities in Lagos. I mean, several communities in Lagos. And I found out that we don't have most of those streets, even though they are named on Google Map or Google Earth. So it was quite difficult locating some communities in Lagos. So how do we, and we find out that some of these streets have been named because Lagos State government recently did some naming of streets and all that. So how, I tried adding some of these streets on the map because I know before now it was, you can do that. You get to a place, you get the coordinates, you add that street or location to the map. But recently, it's a problem. You can't do that actually. So I want to know, is there another way to do that? And then the other one is if I have coordinates of places I want to place on the map and then download, like I tried doing something like that on Google Earth, where I have coordinates of the different locations where we have our schools. And then wanted to plot that on the map, especially Google Earth, and then download it so that we'll have a large view of what it's like in Lagos State and in Osun where we exist. So, but it's not really, so we have them clustered together. So even when you want to expand and make it big, you just have them in packets. So is there an application apart from Google Earth that I can use to do something like that? Thank you.
Yeah. Your first question on what's your first question again? Yes. Okay, yes. So actually the way Google Map works is that it is mapped. It's not that it's Google as a company that will come to your location to map your location, or come to a village to map your village. It is you, the villager, that will map it, and then give Google the data, and the data will Google will make the data available to the public. So, what you need to do, if you go to Google/map, of course, you need to create an account. You can add locations. You can add location of businesses, companies, addresses. It's free. It's open. It's called crowdsource mapping. So when you add it, Google will verify it. If they confirm it, they will add it to their database. They will commit it to the database. Another option is OpenStreetMap. It's also another crowdsourced mapping platform. OpenStreetMap. If you go there, register, add maps of places that doesn't exist. They will verify it and commit it to the database. So, and the last question you talked about, you have captured coordinates of places, and when you plot them on the map, they were in one place. So probably you are using a wrong, what they call it, datum. Okay. Okay. You want to download a large rectified imagery. Yes, there are tools for doing that. Maybe if I come down, you will meet me one-on-one and I will give you. Thank you. You're welcome.
Okay.